Hello everyone, myself Bhavani, Assistant Professor in IT Department in SMIT. We are going to see about symmetric key distribution method. Actually, in cryptography, the same secret key is used by both sender and the receiver for encryption and the decryption data. Most challenge is how to securely distribute the secret key before communication begins. It is delivered physically between the parties. Same both key shared between sender and then receiver. Actually, first know about what is symmetric key distribution. Nothing but it refers to the technique used to secure share a single secret key between communication parties over a network while preventing interception or misuse. Only key can be encrypted using another shared key. Trusted key distribution centers are used. Session keys are generated dynamically. Long-term master key reduce frequent exchanges. Centralized distribution improves control, vulnerable if the KDC is compromised, and then widely used in secure network system. The problems arise in symmetric key distribution will be secure initial key exchange, and then scalability, large number of users will be there, risk of key compromise, secure storage of shared keys. These are the problems in symmetric key distribution. And then symmetric key distribution follows the method of physical and manual distribution. That is the only method. Key is delivered physically through USB or smart card on papers. It's very secure and then it's not scalable, impractical for networks. Key distribution using a trusted third party. That's KDC. It's nothing but it's trusted server that shares secret keys with all users. The working principle will be each user shares a long-term secret key with the KDC. When two users want to communicate, they request a session key from KDC. KDC automatically generates its own session key. It is secure sent to both users. Example for this KDC we can tell Kbros, which reduce the number of keys, provide authentication by itself, and single point of failure. Same using symmetric key distribution using asymmetric encryption. The method which is using asymmetric encryption that tells that secret key is encrypted using receiver's public key. That's most important we need to note about. And then combines asymmetric and symmetric cryptography. They use during the session establishment. And then most important Diffie-Hellman's key exchange. It allows two parties to generate a shared secret key over an insecure channel. No prior shared key required. Vulnerable to man-in-the-middle attack unless authenticated. That's more important. In Diffie-Hellman's key exchange, it's a secure key arrangement agreement, but it doesn't require authentication for safety. Why? Because it's automatically authenticated. It's a secure key agreement. And then let us talk about session key distribution. Nothing but it's a temporary session key is generated for each communication session, often distributed using this KDC method. Improve security by limiting key exposure. The types will be of two types, master key and then session key. Master key will be long-term key shared with KDC. Session key refers to short-term key for data transfer. Let me tell you advantages. It's fast encryption and decryption, low computational cost, suitable for bulk data encryption. Disadvantages, its secure key distribution is difficult, poor scalability in large networks, key compromise affect communication security. Okay. Then distribution of public keys. Public key cryptography uses a public and private key pair. Public key must be distributed securely. Incorrect public keys lead to impersonation attacks. Public announcement can be used but are insecure. Public directories store verified public keys. Direct exchange is possible in small networks. Trusted authorities validate public keys. Certificate provides authenticity and trust. Public key distribution problems. Attackers can substitute fake public keys. User may trust incorrect key unknowingly. Manual verification is difficult at scale. Central authorities may become single point of failure. Revocation of compromised key is complex. Key freshness must be ensured. Secure storage of private key is required. These challenges lead to certificate-based system. Actually, see man in the middle attack. And attackers intercept the communication. Attackers replace the legitimate public key with their own. Both parties unknowingly communicate with the attackers. These impact actually confidentiality and authenticity are lost. See, moving on to public key authenticity problem, there is no inherent way to verify who owns a public key. Anyone can claim a public key belongs to someone else, but same public key authenticity problem impact impersonation and then identity spoofing because it's possible. Okay, moving on to X.509 certificate. It's nothing but it's a standard for public key certificates. Most important. Certificate binds a public key to an identity issued by trusted certificate authorities. Contains subject name and public key. It includes validity period information and then digitally signed by the issuing CA and then prevents public key substitution attacks. Widely used in SSL and TLS and secure email. Let us talk about X.509 certification briefly. Okay, the certification which is held by the structure format also. It has the separate version number, serial numbers, and the signature is most important. Version number specifies the certificate format. Serial numbers uniquely identifies the certificate. Signature algorithm identifies the signaling method. Issuer fields identify the CA. Validity period defines start and expiry dates. Subject fields identifies the certificate owner. Subject public key info stores the public key, extension and then additional security features. These are the formats used for the certificate. Let us see what is discussed about X.509. See, it also consists of public key infrastructure and all. Let us see PKI infrastructure. It's a framework for managing public key. It includes hardware, software, and policies. Registration authorities verify. Okay, it's defined through the revocations. Let us talk about the public key infrastructure. Okay, authentication, confidentiality, and integrity. Let us speak about authentication, how it process. Okay, let us see how it discussed. See, it is very confidential and then it's used in banking, e-commerce and e-governance sector and all. Okay. let us see briefly about the X.509. Okay, certificate. This is most important. See, they are standard format. Okay, X.509 certificate we need to discuss before this public key infrastructure. It has the standard format used in public key infrastructure. Okay, to secure bind the public key with the identity of a user or devices or the organization. They play a crucial role in solving public key distribution and authentication problem. Actually, before we have been seen about the X.509 certificate, it is a digital certificate that contains a public key, identifies the owner of the key, digitally signed by a user trusted authority. It's an international telecommunication union. Why we need this certificate? Because we can get the troubles from man in the middle attacks, public key authenticity problems, or impersonation attacks. The certificate has the structure also with the version number, serial number which is uniquely assigned by the CA, signature algorithm, most important, it has signature algorithm that used to sign the certificate, and then issuer, certificate authority, the CA who issued the certificate, and then valid period, whether not before or not after, and then subject, entity to whom the certificate belongs to, and then subject public key info, public key or algorithms has been used, and then using extensions, usage constants, and then digital signature. Okay, this is most important. And then certificate authority, like who is authorized to have the certificate and with whom we have been received the certificate. It verifies the identity of the subject, and then issuer, and then maintain trust of public key infrastructure. Now let me tell you about the public key infrastructure. See, it's a framework for managing public keys. It includes hardware, software, and policies. Certificate authorities issue digital certificate. Registration authorities verify user identities. Public key infrastructure supports certificate revocation. Ensure secure communication over networks. Enable authentication, confidentiality, and integrity. It also used in banking sectors, e-commerce, and thank you.